Imagine navigating a massive enclosed labyrinth. You can map every corridor you walk down, but you strike an invisible barrier the moment you try to determine the exact coordinates of the exterior walls. You are an embedded observer. Mapping the structure requires finding a way to measure a system you cannot step outside of. Clinical psychopharmacology typically approaches this problem by treating psilocybin dosage as a scalar variable. Researchers titrate the quantity upward, seeking a magnitude that produces an optimal therapeutic effect. This relies on a specific misconception, the scalar fallacy. It assumes the observer's cognitive architecture is a uniform field that will yield in direct proportion to pharmacological amplification. The Observer Embedded Reality Framework, or OER, treats dosing as a structural coordinate system. In this topography, the primary variable is the specific location where the dose lands within the observer's mental landscape. Every observer is bounded by an epistemic ceiling. This represents the dynamic inner limit where reliably available cognitive traversal ends and actively defended psychological architecture begins. Single-session protocols produce profound experiences that the observer can deeply feel, but they ultimately fail to locate the ceiling. Without multiple coordinates, the observer remains unable to specify where in their architecture the experience actually occurred. To pinpoint that location, the OER triangulation protocol employs a distributed architecture, a 3-gram morning dose, a 3.5435-gram midday apex, and a 3-gram evening anchor. The 4-decimal precision of the 3.5435-gram dose identifies a derived threshold. It functions as a load-bearing engineering specification rather than a flexible clinical guideline. This precision is governed by the absolute uncertainty principle. This rule dictates that perfect parameter precision actually degrades reading resolution because the architecture being measured is a field rather than a single point. To understand how this paradox maps the limits of cognition, we have to reverse engineer the protocol. This requires treating the mind as a mechanical field to be triangulated. Measuring the epistemic ceiling begins with the neural substrate that generates it. The temporally aligned coherence model shows cognition is discrete. Our brains integrate information in gamma band bursts lasting 100 to 300 milliseconds. Subjective continuity is a constructed illusion. By precisely aligning these events, the brain produces a seamless experiential flow. In pathology, this alignment becomes dysregulated. A common misconception is that pathological overcoherence results from excessive synchronization. Overcoherence is actually a coordination failure. Internal models become so rigid the system cannot update. The machinery becomes unresponsive to error signals. Because our sense of continuity is generated by this embedded machinery, we remain structurally blind to our own defensive boundaries in waking life. Mapping them requires a protocol that bypasses this biological concealment. In this coherence field, valleys are traversable, peaks are defensive gradients. The 3-gram morning dose scans the stable baseline. The 3.5435-gram apex pushes orthogonally during the plastic circadian trough. The 3-gram evening dose captures motion, locking these coordinates to pinpoint the ceiling. Temporal asymmetry is a mathematical requirement for this process. 3 structurally distinct neural states are needed to distinguish genuine architectural signals from pharmacological noise. The 3.5435-gram apex is the product of 2 specific variables. A 3-gram baseline yields 2.156 grams of active psilocin. Midday plasticity drops 18.12%. Multiplying this coefficient reveals 0.3907 grams of additional psilocin required to register a signal. Converting this via the molar inverse adds 0.5435 grams, deriving the 3.5435-gram apex. Undershooting this number results in a signal that drops below the detection floor. The amplification contacts the ceiling, but lacks the pressure required to distinguish architectural information from general awareness. Overshooting the threshold enters the destabilization range. The error signal is generated, but the meta-representational layer, the internal instrument required to read that signal, breaks down. 3.5435 grams identifies the narrow corridor between the detection floor and the destabilization threshold, the only space where error correction is possible. This derivation raises a question. If the numbers are load-bearing, why does the framework tolerate protocol deviations, such as a 52-minute delay on an evening dose? These values are the optimal midpoints of an axiom axis. They represent the deepest points of a structural tolerance band, where the protocol's relational invariants hold true. The absolute uncertainty principle explains that because the mind is a field, extreme point precision artificially narrows the sampling area. Attempting to measure with infinite precision captures only a fraction of the wave, while a wider band allows the full shape of the field to become legible. This limit is a structural feature of field sampling, distinct from the uncertainty found in quantum mechanics. It is a universal constraint. The Nyquist-Shannon sampling theorem establishes that a signal cannot be resolved above a certain frequency relative to its sampling rate. Similarly, the optical diffraction limit defined by Ernst Abbe shows that features cannot be resolved below the wavelength of the probing instrument. Deviations within the protocol's tolerance band trade coverage for resolution. They prove the observer's mind is reacting as a mathematically measurable field rather than a set of discrete, unrelated events. The formal mathematics of the protocol lead to a significant clinical and philosophical conclusion. Triangulation produces a structural address, pinpointing exactly where an observer's available traversal terminates. It defines the specific location, gradient, and momentum of a defensive psychological boundary. Most observers maintain an implicit, often imprecise model of their own minds, a systematic misreading of where their actual boundaries sit. By replacing this guesswork with a verified coordinate, the protocol performs epistemic error correction. This framework forces a shift in perspective. The mind is a dynamic structure mapping itself from within, rather than a vessel to be filled with pharmacological amplification. The OER protocol demonstrates that finding our own limits is not a matter of simple introspection. It is an act of rigorous, triangulated engineering.